Welcome to The Explainer. What if I told you we could tackle one of tech's biggest problems with something that sounds like it's straight out of science fiction? We are diving into a pretty wild new thesis today about a supercomputer that literally powers itself by pulling energy from empty space.
So let's just start with this big idea. Imagine a supercomputer powerful enough to, cure diseases or maybe even reverse climate change. Got it? Okay, now imagine that same machine was so incredibly efficient that it actually produced more energy than it used. We're talking about a computer that not only solves our biggest problems, but helps power our cities while it's at it.
I mean, that's the dream, right? But the reality, well, the reality is that the next generation of supercomputers, these quantum computers we hear so much about, they're on a collision course with a massive energy crisis. A huge one. Because as we try to make them more and more powerful, their appetite for energy is it's scaling to completely unsustainable levels. Okay, so let's get into it. What exactly is this energy wall that's holding quantum computers back? Well, it really all comes down to the absolutely staggering, almost unbelievable amount of power these machines need just to be switched on. All right, check this out. A current quantum computer, right now, with just over 400 qubits, it already uses about 25 kilowatts. For perspective, that's enough to power a whole street of houses. But here's the kicker. To get to a million-qubit machine, which is the scale we really need for those world-changing breakthroughs, the power demand just skyrockets to a mind-boggling 260 megawatts. And to put that into perspective, 260 megawatts, that's basically the entire output of a small nuclear power plant. A whole power plant for one computer. You can see the problem here. That's not a viable path forward. It's a total dead end. So this energy wall, it seems unbreakable, right? So if we can't solve this with just, more conventional power, it forces us to ask a pretty radical question. What if we could find a totally new source of energy, one that's built right into the computer itself? And this is where things get really wild. A new thesis from a researcher named Rolando Garcia proposes something that honestly sounds like it breaks the laws of physics. The idea? To harvest limitless energy directly from the quantum vacuum. From the empty space that's all around us. Now, hold on, because this isn't just some wild guess. It's actually based on a real, totally measurable thing called the Casimir effect. See, quantum physics tells us that empty space isn't empty at all. It's like this buzzing, chaotic sea of tiny particles constantly popping in and out of existence. The Casimir effect is the physical force, a little push and pull from all that activity. And it's the proof that there's this enormous, untapped energy source just hiding in plain sight. Okay, so the big question is, how could we possibly harness this exotic energy? Well, the research proposes it's not just one single discovery. It's actually a brilliant three-part breakthrough. So the solution has these three really elegant, interconnected parts. First, you need a special kind of material, one that's designed to interact with the vacuum. Second, you need some sort of engine to actually pull out the energy. And third, you need a super efficient way to get that power exactly where it needs to go. All right, first up, the material. Picture a sheet of graphene. It's like a perfect one-atom-thick net. What the researcher did was strategically weave atoms of lithium and nitrogen right into that net. Now, this isn't just adding stuff in. This co-doping, as it's called, creates this incredible synergy. Think of it like cooking, where two ingredients together create a way stronger flavor than either one on its own. It makes the whole sheet of graphene super sensitive to all that energy in the vacuum. Okay, next, the engine. So it uses this special graphene to create these tiny vibrating membranes. You can think of them like microscopic drum skins. The energy from the vacuum actually pushes on these little membranes, making them vibrate. And that vibration, it gets converted directly into usable electricity. Yeah, it's literally pulling power out of thin air.
And finally, how do you get that power where it needs to go without wasting it? Well, you use what's basically an energy GPS, and it's based on that wonderfully weird quantum principle, entanglement. It essentially teleports the energy to its destination with just unbelievable efficiency. Let me put it this way. Normal energy transfer is like trying to pour water from one cup to another. You're always going to spill some, right? In classical physics, you literally can't do better than 50% efficiency. But this quantum method, it's almost perfectly lossless. So all of this, it sounds incredible, right? A perfect trifecta of new technologies. But the all-important question is, did it actually work? Well, the experimental results that are laid out in the thesis, they're absolutely stunning.
First off, that wonder material, it totally delivered. The measurements confirmed it. This special graphene amplified the harvestable energy force by over 8 times. 8 times compared to just regular graphene. So the very foundation of the whole system was proven to be incredibly effective.
Okay, second, that energy GPS, the entanglement system achieved an unbelievable 96% directionality. Now remember what we said before? Classical physics says you can't get past 50%. It blows that completely out of the water. It ensures that almost none of that precious harvested energy goes to waste.
So you put it all together, and what do you get? The final power output is, well, it's astounding. The system generated 170 watts of pure, clean power for every single square meter of the material. And all of it, every watt, was drawn directly from the vacuum. But what does that actually mean in the real world? It means a tiny little chip, just 1 square centimeter. We're talking about the size of your thumbnail, could generate enough power to run a 200,000 qubit quantum computer. This doesn't just change the game, it completely flips the entire energy equation on its head. And here it is, the ultimate proof, the final energy balance sheet. The system generated 2,550 milliwatts, while the computer itself only consumed 2,440. Do the math. That leaves a net positive of 110 milliwatts. It's not just breaking even, the computer is now a net energy producer. Wow. Okay, let's just step back for a second. What does a self-powering, energy-producing computer actually mean for us and for the planet? I mean, the implications of a breakthrough like this they're enormous. This goes way beyond just making computers work better. Just look at it from an economic angle. The numbers are staggering. The projected 5-year costs of a big million-qubit quantum computer could plummet from a truly astronomical $38 billion all the way down to around $420 million. That's a game changer. It makes this incredible technology vastly more accessible to almost everyone. And then there's the environmental impact, which might be even more profound. Because it's feeding its extra energy back into the power grid, the computer isn't just carbon neutral, it's actually carbon negative. For every single hour it's running, it's effectively removing 320 kilograms of CO2 from the atmosphere just by offsetting dirtier power sources. That is huge. So what we're looking at here is research that could transform high-performance computing from being a massive energy problem into an actual environmental solution. It fundamentally changes our relationship with both information and energy. Which leaves us with one final question. And it's not just exciting, it's essential. If we can start powering our most advanced technology with the very fabric of reality itself, what's next? What else is possible?